All right. Let's try this question, please. This stuff says complete the reaction, this, and then name the product form. The question here said, you should, okay, what is the name of the reaction? What of the reaction? Obviously, it's oxonolysis. Of course, oxonolysis has to do with when you combine ozone and something else. So the answer is oxonolysis. That's the name of the reaction. Now, what will be the product of this? First things first, what's the name of this compound? 1, 2, 3, 4, 5. That is cyclo. Cyclo 5. Cyclopent. Pent, there's a double bond, pentene. So cyclopentene, this man, hope good enough, is attached to this carbon bearing the double bond. So most likely you can start a numbering from here. Right. So it becomes what there? 1-methyl cyclopentene. Or if you want to stress, 1-methyl cyclopent 1-ene. But I think it's not cyclopentene. But let's use this as 1-methyl cyclopent. Should we use pentene or pent 1-ene? They're the same thing technically. Cyclopentene. So far the one, it's here. But then, fine. Let's use 1-ene. All right. If 1-methyl cyclopent 1-ene undergoes ozonolysis, what is formed? Take down, please. The product of the ozonolysis of 1-methyl cyclopent 1-ene, the product of the ozonolysis of 1-methyl cyclopent 1-ene is a mixture of two compounds. Which are, number one, methyl cyclopentane 1-ol. Methyl cyclopentane 1-ol. 1-ol, like alkanol, alcohol. So that should be 1-methyl, please. The product of the ozonolysis of 1-methyl cyclopent 1-ene is a mixture of two compounds, which are, number one, 1-methyl cyclopentane 1-ol and 1-methyl cyclopentane none. And 1-methyl cyclopentanone. 1-methyl cyclopentanone by alkanone. So please try to draw the structure. I've talked about alkanone. So see if you can get at the structure, please. All right, please, let's get this done, please. So first things first, please. We said if you do the oxonolysis of 1-methyl cyclopent 1-ene, you have what's the first in there? So pent 1-ol, that's pentanol. Cyclopentanol, you should know what it looks like. Cyclopentanol depends on the author. Some will choose to write their cyclopent structure like so. This is a way of writing cyclopent structure. Others will choose to do this. To do this. A C-cyclopent. Yeah. So you can do this. Let me use this structure now. So what I'll have there, I said 1-methyl cyclopentane 1-ol. Cyclopentanol. So this. All right. So I have this. Let me draw it properly, please. All right, so that's a cyclopentane. To make it a cyclopentanol, it means put what there? OH. So this now becomes cyclopent one all or cyclopentanol. Since they say one methyl, it means methyl should be attached to that same point. This carbon here has one, two, three. There's still space for one. So hence, we can come here and put CH3. All right, so this becomes one methyl cyclopentan one all. So you say we have two products. This plus what again there? Plus what? Get the parent atom or the parent whatever thing there. That's arcanone. For an arcanone, what's the key thing there? C double bond to what there? O. Right. So cyclostructure first. This. So cyclopentane. To make this a cyclopentanone, I have to put this here, which is called arcanone. So you should know what this means. So cyclopentanone, that's this. Some persons would rather complete the structure more like there's been no space here. I'll do this. All right, more like this. So this is cyclopentanone. There's no way I can have a one methyl cyclopentanone. Because for you to have a one methyl cyclopentanone there, that methyl has to be here. If there's no space, the carbon here already has 1, 2, 3, 4 bonds. So I have to move that man here, CH3. So instead, it becomes what there? 2 methyl cyclopentanone. So that's this. So please, the product of the ozonolysis of 1 methyl cyclopent 1 in is 1 methyl cyclopentan 1 all and 2 methyl cyclopentanone. All right, so that's what you have. So you get as an answer. So that's your answer, please. All right, so in class, they said if you do ozonolysis of this, you get this, right? So I don't really know how they came about these products, but from research, you make your research, go online, make research. What you find is, especially this one. This one I even got first. It was later on further research that now saw that it's a combination of this and this. But what you see majorly, do your research, is this one, majorly. 2 methyl this, and then this one here. How they got this one? Perhaps from higher minds. But really, I can't tell. How do you even start to name itself? Can't you tell? Because if you attach carbon here, it's not even balanced. Right, so this is what they gave them as the answer. So perhaps go make your checks on what, if this exists, and what it is. All right, let's try this one, please. What kind of isomer does 1,2-dibromo-18? 1,2-dibromo-18 exhibits? What kind of isomer does it exhibit? The answer is geometrical isomers. That's cis and trans. Geometrical isomers, cis and trans. This one is what? This one, what do you have here? Trans. All right. Trans 1,2 dibromo 18. Uh, that name, is it correct? Huh? Is it correct? Trans 1,2 dibromo 18. Is it correct? Huh? When I named it, it looks correct, but then I remembered something. Always note that there's always this, whenever you have the concept of tautology, cancel it out. I said before that there can be nothing like one pentanol, right? Why is there no one pentanol? Because two pentanol cannot exist, right? Pentanol, one, two, three, OH, H, H, uh, sorry. Is it pentanol? Prop. Sorry, sorry. It was not for the all. It was for the alkene. I was saying one propene, prop, one, two, three. Uh, this, one, two, C2, two, three, four, one, two, three, four, one, two, three, four. What do you call this? Huh? Propene. If I say one propene, is it correct? It says propene now. If I say one propene, is it correct? Yes. It's not really. Why? If you say a one propene, it means I'm expecting what there? A two propene. And technically, two propene cannot exist. Because if there are only two possible positions for my double bond, that's either here or here. At this point is propene, or as you say, one propene. If I choose to move this one here, it still becomes what there? One. So there is no two. So better still called what there? Propene instead of one propene. Don't stress the one because there can be no two. The same thing is happening here. Why are you stressing the 1,2 dibromo when technically there can be no 1,1 if it's trans? Get the concept. First of all, if it's trans, that means these two have to be opposite. If it's an 18, that means I have two carbon. That means the only free space for the bromine is just here and here. That means there can be no 1,1, there can be no 2,2. So me saying 1,2 dibromo is like a tautology. Get the concept. Trans would mean these two have to stay opposite. 18 means I have two carbon only. So if these two are staying opposite and I have two carbon there, the only space I have to work with is just here and here. So it will always be 1,2. More like. So what should it be there? Trans dibromo. Yeah. So better still. Um, and then get the cis. For cis, what will it be? Get the cis. For cis, what will it be? C double bond C. I have H. I have H. I have Br. I have Br. So what will this be? Cis dibromo 18. So I'm having this. Somehow, somehow again, I'm saying if I want to say trans 1,2 dibromo 18, it's okay. But note that you're saying 1,2, it cannot be more than 1,2. It has to be 1,2. So technically, it's a tautology. That's what I'm saying. So if you still want to put trans 1,2 dibromo 18 and cis 1,2 dibromo 18, that's for you. That's for you. Next question here says 2-methyl 2-pentene undergoes oxynolysis to give what? So oxynolysis of 2-methyl 2-pentene, 2-methyl 2-methyl 2-pentene, pent. 5, Abby? 1, 2. I'm adding CH3 here. 2-methyl 2-pentene, double bond, CH 1, 2, CH 1, 2, 3, 4, 2, CH3. This should be 2-methyl 2-pentene. Abby? Yep. So 2-methyl 2-pentene. This is 2-methyl, or you can say pent 2 in 2-methyl 2-pentene plus ozonolysis. To give you what there? This will give you an ozonide. What does your ozonide looks like for this? What does it look like? If you can remember when I showed you ozonide, I'm hoping this space will contain. I said for ozonide you have C, Abby, to what here? O to C, Abby, to O this. And I said the way you divide this is based on this, Abby. To become C, I said this H will be here. That's CH, CH2, CH3. So it becomes CH2, CH3. This is your ozonide. So I said when it comes to ozonolysis of an alkene, it will divide from where you have double bond. This will be at the right side. So CH, that's this, CH, and then CH2, CH3. This one will be at the left side. So it becomes C into, I have CH3, that's this and this, and then this and this. I now still have CH3. This is my ozonide. I have this. All right. Please check from your stuff there. What was next there? Check that reaction if you can remember. That was zinc and what? Water. Please check. I gave this one earlier. Go to alkene, you see this. So this will now give you propanone and propanal. For a propanone, what do I expect? C, double bond to oxygen, Abi. For a propanone to have alkyl group on both sides, Abi. So this will be what there? CH3 and what again there? This becomes what there? A propanone. We talked about alkanone and alkanal. We said for alkanone, this becomes a propanone. For alkanone, the carbon bearing the OH is attached, the two sides are attached to alkyl group. So if it must be prop, one side has to be one carbon and the other one, such that if I combine it becomes 1, 2, 3. That's this. Plus propanal. For an alkanal, the carbon bearing the what? O is attached to what there? Hydrogen on one side. Then if it must be a propanal, I still need 3 carbon atoms. So it becomes CH2, this is 2, and then CH3. This now gives you propanal. So it's an alkanal because on one side I have hydrogen, as we explained before. So I have this. So this is what you have, please. That's your answer. All right. This question says, what condition or conditions are required to produce trans-but-2-ene from 2-butyne? All right. 2-butyne. If it's a butyne, that means both CH3. This is 2-butyne. The ine is showing triple bond 2. Triple bond is in carbon 2. 2-butyne would be under lithium or sodium and liquid ammonia to give you trans. For a trans, they have to be opposites. So CH3 and then CH3. This is H. This is H. This is trans both to in or trans to butene. So what condition? This is called bridge or this is the name of the reaction, bridge reduction. The condition is that you have lithium or sodium in aqueous or liquid ammonia. In liquid ammonia. That's the condition, please. All right, so this must be passed through lithium or sodium in liquid ammonia called bridge. How do you pronounce this? Huh? Birch. 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 B. Bird. Birch. Okay, birch reduction. All right, so that's the answer. One last one, please. One last one, please. All right, let's look at this, please. Diction says, which trend best describes the increase in acidity of the hydrocarbons below? In acidity of the hydrocarbons below. You have this. Take that, please. Of course, if you look at this clearly, they are just asking between alkane, alkene, and alkyne. Which of them is most acidic? All right. So in order, so depends on how you want to take it. You can take it in order of increasing acidity or decreasing acidity. But whichever one, bear in mind that alkynes are the most acidic of three of them. So let's do this. Let's take this, please. In order of increasing acidity, in order of increasing acidity, comma, we have all right, this. So if I should use this one here, it means the alkane first, which is this one, single bond. So the alkane is like lesser than the alkene H3C, no, H2C, double bond C2H, that's CH2. Uh, that's H2C, double bond CH2, less than alkyne HC triple bond CH. That's in order of increasing. If it's order of decreasing, what will it be? Alkynes were there greater than alkene greater than alkane. So I think that's the answer to this question.